Hi everyone, I wanted to make a video explaining some of the concepts from measurements of variation. I want to start by saying I'm still sick, so I apologize if I am sniffling or start coughing or sneezing in the middle of this video. At least you're watching me through the internet, so you don't have to catch what I have. In this video I want to talk about the regular standard deviation, I want to talk about the mean absolute deviation, and I want to talk about the coefficient of variation. So I've just Googled all these terms and I'm grabbing whatever comes up. It should be the same concept no matter where you are, so I highly suggest that you get in the habit of Googling these things. There will be a website that does the best job for you of explaining these concepts. It may be our discussion boards, it may be our book, it may be emails with me, it may be my videos, and it may be Khan Academy, it may be any other website. So just keep your perspective open until you find the website that works best for you, or the means for learning this information that works the best for you. So I'm going to start with the regular standard deviation, and I want to look at the equation for it and what exactly we're trying to do with it. So I'm going to open my magnifier so we can see the pictures I'm looking at. So this is just some data from a stats class. It looks like we're looking at the metabolic rate in male and female Fulmers. I don't even know what that is. But regardless, we're looking at metabolic rate in male and females. Okay, so we can definitely see that the spread of the data here for males is much wider than the spread of the data for the females. So the black dots are representing individual pieces of data, and the red dot should be the mean for the data. So looking at this, I can see that there are black dots very far away from the mean, the red dot for male, and black dots very close to the mean for female, which means that my standard deviation for females should be much smaller than my standard deviation for males, because standard deviation is a measurement of the spread or the diversity of the data. So we needed a way to measure this, and all the statisticians in the world got together and picked a method. Just kidding, that's not how it really works, but we did come up with a formula, and that formula is over here. What we decided to do was take each individual piece of data, this x sub I, and see how far it is from the mean, which is the x bar. So in this formula, we are using subtraction. And we get used to saying subtraction or negative in our math classes, but what subtraction is actually representing is the difference between two things. So stop saying subtract in your head and start saying the difference. So I'm looking at the difference between each value of my data and the mean. So this little piece of data right here is above the mean. So the difference between this piece of data and the mean should be some positive number when I look at the difference between. So it looks like this one's like 2,000 and the mean's sitting somewhere around 1,200. So I should have a difference of about 800 positive. Whereas this little piece of data down here is far below the mean. So when I do a subtraction, I should get essentially negative 800. And since the mean is supposed to be in the middle of the data, that will continue to happen. I'll get numbers very large and positive away from the mean, and I'll get numbers very large and negative away from the mean, and then I'll get numbers small and positive away from the mean, and small and negative away from the mean. And if I just straight add those up, I should get essentially 0, because I've got a bunch of positive numbers and a bunch of negative numbers. And if I add up all the positive and negatives, they should balance each other out, and I should get 0. So if I just straight added and then divided by the number of pieces of data I have, I would get that the mean difference of all the pieces of data from the mean is 0. And that doesn't tell me anything, because it would be 0 for this data set and 0 for that data set. So we had to come up with a solution to stop getting 0. And the solution that was chosen was to square. So if I take the difference and I square it, then it forces it to be positive. And I can look at the average of that squared difference. And then taking the square root will fix our units for us. So the square kind of cancels out and we don't end up with squared units. Okay, so how does that help us? Well, that allows us to look at the difference and actually get a number that isn't 0. Okay, why wouldn't we use absolute value? Squaring things is difficult, and then I have to take the square root to undo it. So why on earth wouldn't we just use absolute value, like the mean absolute deviation does? And the answer is complicated, because it's statistics. Most of statistics and the math we're doing is based on calculus, but calculus isn't a prereq for our class, so we can't really delve into the whys of a lot of why these formulas are the way they are. And the long and short of it is that when I'm dealing with this formula in higher level mathematics, the square and the square root are a lot easier to do math with than the absolute value function. The absolute value function is a very special function that doesn't always work well in calculus. So the squared function does. And that's why we went with this squared function, because it will work well in our higher level mathematics. But that doesn't mean the absolute value is useless. It still gives us useful information. And so that is where the mean absolute deviation comes in. Close this. Okay, so the mean absolute deviation is that idea. It's the difference between each individual piece of data and the mean, and then absolute valued, so I get rid of all the negatives, and divided by n. And this gives me an average of the distance between each piece of data and the mean, which gives me a nice way of estimating that. But it doesn't work well with higher level mathematics. So it's kind of like what would I call that? It's contained within itself. It really doesn't work well outside of the idea of MAD. So standard deviation I can use in this cool curve. I can use in higher level mathematics. I can use with working with probabilities. But mean absolute deviation, or MAD, gets limited very quickly. So that would be why we stick with standard deviation so often. But our book does want to emphasize that there's different ways of calculating deviations, and there's lots of ways of looking at the data to see how diverse it is. Last thing I want to talk about is coefficient of variation. Coefficient of variation comes in really handy when we're trying to compare apples and oranges, which I know we're not supposed to do, but coefficient of variation allows us to do that. And it does that by taking standard deviation and dividing it by mean, which makes all of our units cancel out. So for example, if I'm working with, let's say, height and weight, then I would get a standard deviation of height, say 2, and a mean of height, say 2, or say 15. So let me open something so I can write this down. So let's say I'm dealing with height, and I find out that the standard deviation is 2, and that the mean is 15. And then I go with weight, and I find out the standard deviation is 5, and the mean is 6. Well, let's pick something bigger, 19. Okay, so I have this data set, I found out these two pieces of information from it, and now I want to know which one actually has more variation. And that sounds like a complicated question, but what coefficient of variation allows us to do is turn that variation into a percentage that doesn't have any units by using division. So standard deviation has a unit. I have 2 inches or feet for height, and weight has a unit. I have 5 pounds or something metric that I can't think of off the top of my head, but pounds. For height, the mean has units, like 15 inches, right? And the weight has units like 19 pounds. But if I do division, then the units would cancel out, because I know, let's say, inches divided by inches, these two things just go away and they give me 1. So if I stack these two, then I should get the units to cancel out, and I essentially just get a ratio of how much they vary. So that math would just be the standard deviation divided by the mean. Okay, don't yell at me. The mean. I can drag that over and do this calculation too, and now I can see that weight has much more variance or variation than height. So usually we turn this into a percentage. Let me go ahead and do that using the percent button, and then we might add a decimal or 2. So now I can see that the variation in height is about 13%, and the variation in weight is about 26%, so I have more variation in weight than I do in height. And that's what coefficient of variation lets us do. So in this article, which is on investment, coefficient of variation is used to see which investment is more risky. So if we have 2 investments and they give us a standard deviation and a mean for how much the return is on that investment, then I can figure out a risk-return trade-off by calculating the coefficient of variation. Which one has more variation? Because if the mean is nice and high and one has less variation, then that one's the safer bet. Whereas if the mean is nice and high and it has a lot of variation, then I could get a really high return or I could get a really low return. So that one has more risk. One more thing I wanted to do was show how these calculations actually work in Excel. So I'm going to do question 9 and question 10 from the homework. So these are both dealing with CV and then with the MAD, the mean absolute deviation. So I'm going to go ahead and view a similar question and start from scratch. I'm going to open this in Excel. Enable editing. And now the formula says to take each piece of data and subtract the mean and then divide by n after I add them all up. So I need the average for the data. I'm going to highlight them all and use this auto sum with the drop down, and I'll just select average and it calculates the average for me. So I'll color that in so I don't lose it. And then over here I need to do the subtraction. So I'm going to equals absolute value, ADS, open parentheses. So now I can do subtraction in here and I'll always take the absolute value of the number. I want the number I'm looking at minus the mean, and I'll just type that in, 1457. And then I'll hit enter. So that's giving me the absolute value of this 980 minus the mean of 1457. I'll drag that down. And now I've got the absolute value of each difference. So here I'm getting the absolute value of 1899 minus 1457. I'm going to add all those up. Auto sum. So this is the summation for the numerator. I've created this summation right here. And now I need to divide by n. So n is the number of individual pieces of data we have, which for this problem is nice and easy. It's 1, 2, 3, 4. But if it was more pieces of data, we don't want to count it by hand, the trick for finding the amount of data you have would be highlighting them, and then the count shows up right here in the corner. So I have 4 pieces of data. So I'm going to take the number I just found out, which is 2046, and I'm going to divide by 4. And that should give me my mean absolute deviation. So I'm going to double check, what does my math lab want? It wants 2 decimal places as needed. So I'm going to add another decimal using my decimal increase button. And now I have 51150. 51150. .50. There we go. Now it wants me to compare it to the standard deviation, the normal standard deviation. So I can calculate that pretty easily. Let me label this. So I have MAD here, and I have the numerator, which I'll abbreviate numerator here. And then I want standard deviation, so SD. Here I'm going to use the standard deviation, and since it's a sample, I'm going to use stdev.s for sample versus .p for population. The denominator in each of these calculations is slightly different, so you want to make sure you choose the right one. This is a sample, so I'll choose .s. And then I'll highlight the data and hit enter. And I've got the sample standard deviation is 594.0174. And again, they want 2 decimal places, so I'll use my decimal decrease button to make sure I have 2 decimal places. 594.02. And then it just asks us for which one is bigger. The absolute deviation of the data is less than, this is the absolute deviation, less than the sample standard deviation of the data. And that problem is complete. So let's go back and look at the CV problem, the coefficient of variation problem. Similar question. Okay, so now I need to calculate the CV for heights and for ages. I'm going to open the data in Excel. I'm going to use the 2 built-in functions for average and for standard deviation, and then I'm just going to take a ratio of the 2 numbers. So I know I need average, and I had a shortcut for that. So I'll put average here, and I will put standard deviation here, and then this will be my coefficient of variation on this row. Okay, so I'm going to equals average right here, and then highlight all the data. So I did A2 through A13 and hit enter, and now I can use my special corner to drag sideways. So I can drag left and right, and I can drag up and down. So it did the calculation of average for B2 through B13. I'm going to do the same thing for standard deviation, And again, this is a sample, so I'll be sure to pick the one with a .s for sample. Highlight the data, again A2 through A13, enter, and use the special corner with the little tiny black cursor to drag sideways. Then I want to create the CV, which is standard deviation divided by average. So A15 over A14. Hit enter, and now I have a coefficient of variation. I can drag that sideways, and it'll again do the same math. Coefficient of variation is almost always given as a percentage of variation, so we want to turn this into a percentage using our percent button. And then my MATLAB would like to have 1 decimal place. So I'll use my decimal increase button to give me another decimal. So I've got 4.2 for heights and 13.5 for ages. So the heights of my players are pretty close together. It has a low percentage of variation, while the ages of my player are more spread out. It has a higher percentage of variation. So now I just need to type those in. Let's see, for heights I have 4.2. Close that. Check answer. For ages, I think I had 13. Ooh, where'd it go? Not you. I had 13.5. Okay. And now, even though I'm measuring two completely different things, heights and ages, I can make a comparison of how much variation each one has and answer that, let's see, ages are more variable than heights. Yes, ages are more variable than heights for all pitchers on this team. Or heights are more variable, which is not true because this percentage is a lot smaller, or they're about the same, which is not true because these numbers don't look anywhere near the same. Okay, I hope that clears up some of the questions with standard deviation, the basics of what it's trying to calculate versus the mean absolute deviation and the basics of what it's trying to calculate versus the coefficient of variation and the basics of what it's trying to show you. So coefficient of variation is a percentage of how much the data varies. Standard deviation is our go-to method of figuring out the deviation or how much difference there is between the pieces of data. And then the mean absolute deviation is a nice way of looking at how spread out the data is, but limits us in the math we can use moving forward.